In the last set of videos, we talked about discrete probability distributions. In this set of videos, we're going to talk about a particular kind of discrete probability distribution called a binomial distribution. To be able to describe a binomial distribution, it's helpful to first know what kind of experiment the probability distribution describes, what outcomes of what experiment this binomial distribution describes. Okay, and so we want to first talk about a binomial experiment. Now, there are three things that are crucial for running a binomial experiment. One, you run a certain fixed number of trials. There are a fixed number of repeated trials. And we usually notate this with the letter n, the number of trials n. So for example, say we roll the dice. Every time we roll the dice is like a trial. Okay, a standard six-sided dice. If we roll the dice 10 times, then there would be 10 trials. So if we roll a six-sided dice 10 times, then there are 10 trials. Okay. 2, the second requirement is that in each trial there's only 2 possibilities. Okay. Each trial has only 2 possible outcomes. And we call these outcomes success and failure. We notate the probability of success with the letter P. The probability of success is P. Now, because there's only 2 possible outcomes, that means the probability of failure is the complement of success, right? You could only do the 2 things. So together, if we look at the probability of success and probability of failure and look at them together, it must be 100% of all the outcomes of this particular trial, right? So the probability of failure is 1 minus P, because 100% represents all, the chance that anything happens at all, right? There's a 100% chance that something happens here. And all we're doing is we're taking away the probability of success. What's left over must be the probability of failure, since those are the only 2 possibilities. Okay? Let's go back to our dice rolling example. Say we are interested in rolling a 2. We are interested in whether or not the dice lands on 2. For each trial. Okay, so then the probability that the dice lands on 2, the probability of success is 1 out of 6, because there's one way that the dice can land on 2 out of 6 possible sides, right? And the probability of failure, which in this case would be the probability that the dice lands on anything other than 2, would be 1 minus 1/6 or 5/6. So that's the probability of success and the probability of failure. Notice we get to kind of determine, we define ourselves what success means and what failure means. Success doesn't necessarily have to be good. Failure doesn't have to be bad. Success just means what are we trying to look for? What are we trying to measure? Okay, if that outcome happens, that's a success. So it could actually be quite a bad thing if we're measuring the number of instances that people get cancer. We might call a success someone getting cancer. That's not a good thing, right? But that's what we are measuring for. Okay, so here there are obviously lots of other numbers we could have landed on other than 2, but in this case that's all we're looking for. So 2 is all we're looking for. If that happens, great. If not, then we count it as a failure. So everything else is considered, anything other than 2 is considered the same kind of outcome. That's a failure. Okay. And then one more requirement of a binomial experiment. Okay. The trials, the n trials of a binomial experiment are independent and identical. Independent and identical. Okay, so every time we run a trial, it's like it's the same thing that's happening. So if we're rolling that dice 10 times, okay, if we roll a dice n equals 10 times, each roll is independent and identical to every other roll. Independent and identical to every other roll. There's not like a special roll, right? Every time we roll the dice, it's the same thing that's happening, right? There's a 1 out of 6 chance that we'll get a 2. There's a 5 out of 6 chance that we'll roll something that's not a 2, which was why this would be a binomial experiment. So a binomial probability distribution probability distribution is a formula that tells the outcome, tells the probability that the outcome of a given binomial experiment results in X successes out of n trials. Okay, that's what a binomial probability distribution is. If we roll that die 10 times, the binomial probability distribution will be able to tell us the probability that out of those 10 rolls, that 3 of them will be 2s, or that 9 of them will be 2s, or that 5 of the 10 rolls will be 2s. Okay, that's what the binomial probability distribution does for us. Now, we'll talk about how we actually go about calculating these probabilities in a future video. For now, I want to focus on the expected value and the standard deviation of a binomial probability distribution. We learned in the last set of videos how to calculate the expected value, or the mean, and the standard deviation of a discrete probability distribution. This is a particular kind of discrete probability distribution. But it turns out for this particular distribution, we can simplify the formula considerably. Okay, So the expected value for a binomial distribution is just n times p, where again n is the number of trials and p is the probability of success. If you think about it, this kind of makes sense, right? If you have 6 trials and your probability of success is 1 out of 6, then you would expect one of those rolls to end up being whatever you're interested in, whether it's a 2 or whatnot. Okay, so the probability is the long-term proportion. So this is just saying how many, if we ran this experiment lots of times, however big n is, if we repeat those trials lots of times, how many times would we expect this result to happen? Okay, how many times would we expect a success? And then the standard deviation is a little bit different. It's the square root of n times p times 1 minus p. So that's the square root of the number of trials times the probability of success of any one trial times the probability of failure of any one trial.